Hello. Okay, first of all, okay. We're doing this mem copy, and the target address has not been set. Yeah, this is fine. This is a small structfolio. What are we compiling here? Oh, yeah. Dest value number is return base 4. So, where is this? Derived virtual return plane floats. Return plane floats. CPP method. Oh. We may not be. Yeah. We are not initializing. Hold on. Virtual return plane floats. So we're calling out to C and then calling back in. Is that what's happening? Yes. Okay. Yeah. We didn't. No check-in returns handling here. See that? Hey, look, it's almost like I knew when I wrote this last week. This is the problem with only working on something on weekends, because you forget. Look, I knew I didn't do this. And then I'm like, why is it crashing? I have no idea. For what reason could it possibly be crashing? Did I play Rain World? Yeah, I played it up to a point. I played it for the first few safe rooms, and then I got to a point where I think it was confusing how to go forward, and or there was a really hard boss or something. I don't remember. Wow. No check-in returns handling here. Okay, so we need to do the same thing. Yeah. So the deal is, what I'm working on right now is the following thing. This is the big picture of what I'm working on. There's a certain calling. Actually, you guys know, because people who saw the stream last week, I tried to do a Weissman score thing with optimizing out return values or extra copies from function returns, right? Because the whole, we picked our calling convention so that would happen naturally and easily. And then I sat down to do like a Weissman score session where we were going to optimize those out. And then I realized, oh, wait, we can't actually do that optimization because there's problems with the calling convention not actually being consistent across all the backends with regard to where the memory lives for return values. And, when you return something, who sets what where. And so what I did off stream was I sort of went and did some stuff to the x64 and LLVM backend. Those weren't the biggest things, but the biggest thing was the compile time execution, which, because I just didn't have a very, I don't know, like, even though I was designing stuff to work this way the whole time, I just didn't think that much about it because that's my style sometimes. I just do stuff without thinking that hard. And so I remember one day I was like all perplexed about what I was going to do because the memory for where to store things in compile time execution doesn't exist. So I was like, I'll just make it return things in a totally different way. And so that was fine up until now. And now I'm like, oh, that was a mistake, because now, so the reason it's a mistake is that what I ended up doing for this was that, the callee to return a value just sort of gives you a pointer to its value on its stack. And then before that becomes invalid, after you've functionally pop the stack pointer, but before that memory gets toasted, you copy it off. And the problem with that is you can't actually elide copies if that's the way that things work. And so the memory has to exist somewhere before the callee is called. And I knew that back when I made this decision, but that there's just so many things going on all the time that I forget sometimes. So I unforgot and then made most of this change. So now the deal is, anytime, it wasn't too hard to change the functions calling other functions in compile time execution, because there's one place where that happens. But there's a few different entry points, like where compile time execution starts. And those entry points have to allocate memory. And yeah, this one isn't. This one isn't. You remember me discussing removing either the caller called side entirely. That's a slightly different issue. That issue, I think Ryan was on this same stream that I'm talking about, and we just started talking about the calling convention generally. That issue is about who owns what registers. Like in C++ or C, for example, if you call a function, it's predefined by the calling convention that some registers, the values are just going to get overwritten. And other ones, you can rely on them not being overwritten. But I think that's an idea that's outlived its usefulness, I suspect. Okay. I'm going to have a little bit of this really weird honey that I got. Hold on. So I went to the farmer's market last week and I got a bunch of honeys. And one of them is this double propolis Colorado honey. And I got it because I liked how it tasted. But it's like, I read the label and it's supposed to be a medicinal honey that you don't even heat up. So I can't put it in tea. It literally says, the text is too small to read on camera. Eat 3 teaspoons a day during a cold, a half teaspoon a day when you don't have a cold, I guess, helps to keep a balanced immune system. Apply inside of a bandage for rapid natural healing. Ladies and gentlemen, the farmer's market. So I'm going to have a half teaspoon. Note that they didn't have anything to say about what's your body weight. They just said a half teaspoon. Is it mad honey? No. I suspect the mad honey is kind of a scam, right? Isn't it? I remember seeing some YouTuber or someone like that do a thing about how he got mad honey. I don't really remember how it ended. Is mad honey the one they got from a crazy mountain? Yes. Honey on wound is legit. I've somehow lived to current age and never heard of that. Is small talk bad? Yes. Sorry, Alan. This is really good. It's an ancient remedy. Yeah, I bet you see it on all the ancient Egyptian hieroglyphs. But you know what about the ancient Egyptians? They're all dead, so the honey obviously didn't work that well. This medicinal honey tastes really good. I want us to figure out the actual ancient Egyptians, because that's got to be really interesting. Whatever was going on. Have I read Romero's autobiography? I have not. I just don't read as much as I should, if I'm being honest. Aliens. I think Halo is a pretty cool guy. How to design interesting puzzles and levels. I have literally an hour-long lecture that I did with Mark Ten Bosch about how to design interesting puzzles and levels. You can look it up. What's the best theory about how they built the pyramids? I don't think there's a plausible theory. Like all the suggestions that people have are just like the blocks are insanely fucking big. And like the blocks around the outside of the pyramid are what people usually talk about. Those aren't even that big compared to some of the stones on the inside. So like you've got to explain how they moved some of the massive stones on the inside. Yeah, no, I mean, that's what I was referring to. I am definitely, so I don't, whenever people talk about ancient civilizations, they often go off on the crackpot trail like really fast. But I think it's obvious that the Sphinx is really, really way older than people think, right? Like if you just look that one up online, it just makes complete sense. Like the Sphinx is like fucking super old. And so like who built that, right? Maybe Halo went back in time and built it. Ever watched Bright Insight? No, I don't know what that is. Don't know what that is. Okay, so the thing about this is when we set up run directives, we do this, and we could probably create the memory for the return values. Yes, okay. Create memory for the return values. Let's call it create the memory for the return values. Bytecode thread lambda. See, now we don't have to comment because we just used an egregiously long. Lambda. Boom. Okay, so now in FFI, we're going to go to this no check-in. Do we have lambda? Yep. Yep. Yep, 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 yep. C++, so I gotta do everything twice. Oh, I forgot to paste this Holio over here anyway. Why? How did I typo this? What happened here? Oh my god. Right. Record. 4140 is the album before Van Halen's 5150. Cool. Ta-da! It's fixed. Dude, it paid off. We weren't one of those Antifa costume leftists who say work is murder. Instead, we went and it's Friday night. We went out and had fun. And then we came home and we did our capitalist enslavement and fixed the fucking bug. Favorite theory is the industrial scale chemistry done inside the pyramids. I'm not sure about that because the pyramids have, like, they're mostly solid, right? So, like, why would you need that giant mass? Like, this is the thing, like, people sort of feel like maybe the pyramids are like a building. It's really not. It's like the main one, you know, the major ones that we're talking about. There's various pyramids around the world, but the major ones that we're talking about are like filled with stone, and there's like a couple of tunnels and a couple of rooms. So, like, why would you build all that? I would be interested in seeing the theory that tries to explain why you would build all that. I think it's something else. Let's run the LLVM tests. Chandler Kruth recently gave a talk on the approach the carbon language is using to replace compiler asks with flat arrays. I mean, I heard some of the other parts of the people were talking about some other parts of the talk, and they sounded like people who didn't know what the hell they were doing. Like, it was talking about how challenging an open problem in computer science it is to map tokens to source code locations, which is the most insane thing I've ever heard. But yeah, I don't know. I mean, did they do something good about replacing the AST with flat arrays, or did they do the standard way that you map a tree to an array? That's what I would be interested in hearing. Did I watch the UFO speakers in that Congress session? No, I mean, I kind of think all the UFO stuff is BS. It just doesn't. Like, I've never heard anything about. The most credible testimony that I have heard is from those pilots, but they could have orders to be saying what they're saying. So, yeah, I don't know. They used a post order tree and an array. Okay, why? My question is why? Like, is it just because the 32-bit indices are going to be smaller than 64-bit pointers? Like what was their reason? Are some of the pointers implicit? Like one pointer per node is implicit because it's the next thing in the tree. I've thought about stuff like that, and it's just too complicated to be worth it. They were there. Yeah, I'm sure they were. It's just, I don't. I'm not saying the UFO testimonies are false. It's just, I don't have a really good reason to believe them. But who knows? I kind of want them to be true, but it doesn't seem true. Said it was the best order for a language with infix operator. See, that's again like how much of your code is infix operators? Like, okay, a subscript is, right? A plus is, a dot is, but like there's so many things that aren't. I don't know. I mean, I guess they did their node count and they said that a lot of the nodes are infix. Yeah, I mean, there's a fair amount of in C++ of infix operators here. I don't know though. I just, I don't believe that. UFOs are meant to distract us from something at some point in the near future. Maybe. I mean, like here's the whole thing about UFOs, right? And nobody that I know has been able to answer this question. We might have talked about this on the stream. So supposedly the story is, yeah, we did kind of talk about this, but to recap, if you believe this testimony, then the US government has been, you know, monitoring UFOs and collecting crashes. Somehow they make them crash um, for like decades and being secret about it. And if that's happening, why is no other advanced country on earth done anything different from that? Like, are they, is China also collecting UFOs and being secret about it? Is the UK collecting UFOs and being secret about it? Like, what's the model there? Do they all only crash over the continental United States? No, because there's a story of the famous one in Brazil or whatever. Um, so like what you would have to have a reason why all these countries are being secret about it. Like maybe the UFOs literally sent emails to every government and said, be secret about us. Like, I don't know. It just doesn't make that much sense. And like, here's the thing, all these countries fucking spy on each other, right? So if somebody else wasn't collecting UFOs, but knew that we were, they would probably leak it. to fuck with us, right? Maybe it's like the intro cinematic to the Battlezone game. Did you guys ever see that? The Transformers movies kind of stole this idea because they don't have any ideas of their own. Remember the Battlezone PC RTS? Battlezone game intro movie. Let's see this. How it's 2 minutes. All right. Computer graphics, everybody.
Cycler, deploy on Eastern Geyser and build Razor. Acknowledge, Grizzly 1. Turret 2, take up position next to Turret 1 at Western Entrance.
This isn't the right movie.
Grizzly 1, radar arrays detect an unidentified craft approaching from the northern canyon.
That's not the right movie. Nobody has the actual... Okay, I think it's this one.
In a ceremony in the Rose Garden, President Eisenhower named Keith Glennon to head the newly formed National Aeronautics and Space Administration, which will also be known as NASA. Sources say the creation of NASA demonstrated that Ike has finally given in to pressures to take a more active stance on competing with the Soviet space programs. NASA's charter will commit the independent agency to researching and developing vehicles and activities for the exploration of space. In separate news, the bodies of two high-ranking American officials were found shot to death in their cars. Geophysicist Andrew Goldman and military strategist William Stahl had served together in the Alaskan expedition to investigate the meteor deposits of the Great 1952 Shower. As of yet, authorities have not found any connection between the bizarre murders.
This is cutscenes in the old days. You would just show a still frame for as long as possible because you couldn't afford that much file size. Also, maybe this is the length of song that they had, and they were like, well, we have to time it to the song.
Precisely on schedule. 9 from the pad on its way to the moon.
Razor. Entrance.
Our raids are complete. Grizzly 1, we have a large force approaching.
Sometimes it bugs me that Armstrong and Shepard get all the credit. But we all wanted to win the Cold War. And we were ready to commit our lives to getting the biometal. The military boys used all the material that had fallen to Earth. And they still needed more. They went looking for a few cowboys to do the job. And in the end, they orchestrated the world's biggest cover-up. They snuck a whole army into space and not a soul knew a thing. Nagging feeling the...
Okay, you know, there was some totally sick cutscene that I'm remembering, but maybe it wasn't that one. Maybe it was on the expansion pack or the sequel or something. I'll never know. I'll never know. Okay. We have successfully fixed the bug. Change the calling convention to make way for return value optimizations. Ensuring that memory for any return value exists to a call. Okay, actually, in FFI, create memory for the return values. Allocates memory that is never freed for run in at compile time. But call could be called many times depending on what's going on. So we will want to change this when we know a good way to do it, when we think of a good way to do it. Okay. Oh, there's another no check-in. There's several. Oh my God. Okay, that's a cowabunga. Okay, this is our value placement stuff. Our Weissman score. Enable this to okay. There's another one there. I mean, I fixed all the crap. Oh, let's make sure Sokoban builds. Debug compiler, so it takes a while. Dude, I just want to keep eating more of this honey. I want to keep eating the honey. But I'm not gonna. I'm not gonna. Not gonna do it. Not gonna do it. Boom. All right. So now let's just, are there more no check-ins? Okay. Now I do have to do something about not freeing this memory, because actually, like, the problem is, well, no. Yeah, I don't know. I don't know what the problem is. Let's think about this generally, right? So the nice thing about an arena allocator, or whatever you want to call it, is you just get memory right away of the size that you want and you're good, right? Okay. Problem with an arena allocator is you can't really free that memory very well. Okay. Now, if you're going to allocate a bunch of things that are the same size, you could use a different thing where there's like 1 bit per slot, and that makes it easy to free things because all the slots are the same size. You don't get fragmentation, etc. All right. But that is not the case here. This is a variable size allocation that we need to make all the time. And this is generally a pattern that we would like to solve. So sometimes, like, it's very, very common in this compiler that we allocate dynamic length arrays that are not even that big, use them for a little bit, and then at some point we kind of would like to free them. And right now we just don't. But for a use case like this, it's like that's more sketch than it normally even would be. So what can you do? Well, one thing I could do is, for example, once you decide to free it, just put that memory back on a linked list somewhere, right? And then when you're going to get a new one, you just check the top of that list. You say, is it big enough? Is it greater than or equal to the size that I'm looking for? Right? And if it is not, then you just go to the arena allocator and get memory, right? If it is, you then reuse it. Now, of course, you can only do that if you could save a next pointer and a size. So the allocation needs to be 16 bytes, but you shouldn't really be dynamically allocating less than 16 bytes anyway, probably. I mean, certainly not. So for something like this, you know, to get memory for this, you would call a special function that says, you know, get, reuse, or newly allocate a thing. And we would just round up to 16 bytes on that. So I could do that. The thing is, there's a lot of places in the compiler where we can't really use that. But there's a lot of cases where we could. Won't this add fragmentation? Well, here's the thing. What do you mean by add fragmentation? We already have plenty of fragmentation because If you're no longer using memory, but it's not freed, that's 100% fragmentation of that memory. So by that way of accounting, we already have a lot of fragmentation. Now, if you mean in cache locality, maybe not. But I'm not sure that matters to that degree here. Now, the problem with the scheme as I described it is as follows. If you grab a giant chunk and you need less than the full size, right? Do we make you remember the full size? Because if we don't, then every time you put it back, it's going to get smaller, which means eventually we won't be able to reuse it, even though there's actually a massive amount of memory there. So maybe we make you remember the size, at which point is not a drop-in replacement for malloc anymore, and we're using more memory because you got to remember the frickin' size, like in the user level structs. The thing is, that kind of limits, if we make you remember the size, that limits applicability of the thing. Okay. Taking a page from other mallocs and stuff, or, I mean, it's kind of an obvious idea, but we could also just have these binned by size to begin with. That makes the logic when you allocate a little more involved and maybe slower. But like, okay, we've got an arena of like stuff that's 16 bytes exactly, because that's the minimum maybe. And we've got an arena that's, I don't know, 17 to 64 or 63. You've got one that's 64 to 256, whatever. And then you've got one for big things. And then when you free stuff, because you asked for the memory at a certain size, you know that the result, there's a limit to how small the result can shrink, because you never can leave that bucket. So that might be good, except it might actually not be good. But again, that starts adding in this kind of complexity that you have in a general malloc. And if you're going to do that at some point, you're kind of just doing a general malloc, right? So I'm not sure how much it's worth thinking about going down that road. The video where I talk about puzzles. Okay. It's this link. Old speech. Old speech at this point. Okay. Offset allocator. Variable bin sizes that don't seem to have a lot of overhead. Let's see. Fast, hard, real-time O of 1 offset allocator with minimal fragmentation. uses 256 bins with 8 floating point distribution, 8-bit floating in a 2-level bit field to find the next available bin. Bin sizes ensures hard bounds for memory overhead percentage regardless of size. Class POW2 bins would waste up to plus 100% memory. Okay, well, something like this would have the same properties as what I just talked about. If you don't remember the size, which you could choose to, but if you don't remember the size, it's going to shrink over time, not really be reusable. Unless, I mean, well, okay. We can always do the thing, there's sneaky things you do when you make allocators. So instead of having the user remember the size, we could always just allocate an extra 8 bytes and store that before the pointer that we give back to the user, and that's how we remember the size, right? Is that a good idea? I don't know. Maybe. Then the bins are not necessarily as useful. Let's just look at how big the source is for this. It's 400 lines. That's pretty good. Oh yeah, I remember him tweeting about this. Now. Or something like that. I mean, he's returning an allocation struct. See, that's maybe... This is a little too C++ for me, but... Where is it? It's in the header file. Okay, so it's 64 bits, but like as a user, you kind of want the pointer. This is not the pointer, right? So you have to map from this to the pointer, which is probably pretty cheap, but still must be done. Right? You could store both if you wanted to just have easy use for your rest of your program. But then again, that's extra memory. And also maybe other weird problems like getting out of sync. That said, if you don't mind storing this other representation, then yeah, it's probably fine. written for allocating memory on GPUs. Yeah, that makes a lot of sense. That makes a lot of sense. You could still follow this strategy for CPU memory. Yeah. Yeah, so the whole deal with GPUs is you don't actually control the base memory, right? To the degree that you do on the CPU typically, right? So you generally have what's called a sub-allocator, which is what you're allowed to write, where it's like, okay, given the memory that exists, how do I break up, well, given the memory that I have access to, how do I divvy that out to different parts of my program, right? So, you know, you don't do like page table stuff and whatever like you might on a CPU allocator. Anyway, I think it's about bedtime for me. This will be a short stream, so you know, but I do want to think about this. If Raphael is still on, because I noticed he's poked in. What I'm just thinking about is, you know, we do all this stuff with arena allocated memory, and that's very fast. And I'm just trying to think about what are some low-hanging fruit ways to recycle some of that memory. Just because our memory footprint is big, but I also, you know, this check-in that I literally just did causes us right now to leak some memory on every callback, for example. And that's not great. We could also just use a heap allocator for that stuff. It's going to be slower. Maybe that's fine. But I do, you know, we have so many, you know, well, okay, here's a thing that's all over the place in the compiler, right? Is like we have these automatically expanding arrays, right? You just say add and it doubles the size of the array and whatever. And then you start, and so you double the size of an array. We copy out the half size. Let's say it's 32 bytes and you add an element past that. So we allocate 64 bytes, copy in the 32 bytes, and then add the new item, right? What happens to that old 32 bytes? Right now, we just throw it away. But next time somebody literally makes an array, they could use that 32 bytes, right? And that would be fine. And there might be an easy thing, like especially when it comes to arrays, because they're all going through the same, like if you have arrays of the same data type, which you do often in a compiler like this especially, they go through the same sequence of sizes as they grow. And so you could just have those somewhere, right? And the question is just, is there a nice way to do that without getting into the complexity of a full-on malloc? And then, so, you know, the thing that I was talking about before is a less domain-specific version of that, where, you know, it's general sizes. General sizes. Anyway. All right. Bedtime for me. We did an hour stream. Didn't spend that much of it actually fixing the bug, but that's good. We talked about aliens. That's good. I'll see everyone later on. We'll probably stream some this weekend. I might, depending on how I feel when I get up, I might do like a mild milquetoast version of Weekend Project. We'll see. Thanks, everyone.